Hello again, welcome to my channel. In this video, I'm gonna do a function called getComputerMove. It's not gonna be anything technical. It's just gonna be it's just gonna be it's not gonna be proper code, but it's just gonna be, what do you call it? It's just gonna be some skeleton code. So what I have to do now, I have to declare some variables, and I'm gonna type them out, and I'm gonna tell you what they are. The first one's gonna be apply, and that's going to be equal to naught. Second one's going to be position, P-O-S-I-T-I-O-N, positions, and that's going to be naught. Let me just put the let in front of it. Third one's going to be maxply. These are going to be global variables. Just like the board really is a global board. Okay. And that's going to be equal to naught. I could have put all of them on one line. I was just thinking. Anyway, I'll leave it like that. Okay. So them three are going to be global variables, and quite a lot of functions are going to use them. But anyway. Now what I'm going to do is I'm going to paste it in, and I think I'm going to do, I may do another skeleton function after this, but I'll talk about it. Now what I'm going to do is I'm going to leave this line in, but this function hasn't been created yet. Okay. Now how can I describe that function? Imagine there's a function, you're passing the board, you're passing the side, and you're passing the maximum depth. And what it will do is it will search every single combination of move to that depth, and it will return back the best score. That's all it does. That's all we want to know. So what it will do is positions. Then three think, in fact, I need another one. I need this best score as well. So let me just create that. In fact, what should I set that to? Let me just set that to -1. Let me think. I'll set it to naught. I'll come back to it. I'll come back to it. I'll set it to one thing. But anyway. So what this does, yeah, I have to change that value. So it can't be that value. But anyway, I'll leave it as that, but I'll change it later. But anyway. So what this does, it gets the best score, but also it's them variables that are created, positions, will tell me how many positions I looked at. The maxply will tell me the max depth that it went to. The best move will tell me the best move, and the best score will tell me the best score. Okay. So every time this function runs, it wouldn't just give me the best score and that will be the end of it. It will also tell me how much, so I can see how many positions it went through. And I may be able to do a test on it by seeing how many positions it looked at. Okay. So this is getComputerMove. Now we haven't done this function yet, so that will be explained in detail. And to explain this, I'm going to have to talk about some other things. Okay. So what I'm going to do is I'm going to create a function. I'm thinking, where can I create it? I'm going to call it factorial, but it's not going to calculate factorials. Let's just call it factorial. But it's not going to create. It's not going to calculate a factorial, and it's going to take a number. And the first thing it's going to do is if num equals naught, return 0. Let's just do return 0. Alright. And what I'm going to create is I'm going to create a recursive function. So what this is going to do is this function is going to call itself. And I'll talk, because what it is, that's what's going to happen. You know that min-max function that I showed you here? That's what that is. It's a recursive function. And I'm going to tell you why we need this recursive in a bit. So I'm going to do it here. Okay. Factorial. We're going to call it. What we're going to do is do num return num plus factorial num minus 1. And what this would do, this if we wanted to find out what's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 8 plus 9 plus 10, this will work it out. So let me check it to see if it's working. I know the answer to 10 is 55. Okay, so that's working. And if I do 100, it's going to be 5,050. Okay. Now there is a limitation. What? Let me just show you something. If I make this a bit wider, can you see that thing that says the stack there? If I could pause this, you'd see the stack. You'll see it go on the stack. Anyway, there's a limit to the amount. The reason why I didn't do factorial, the one where you multiply, is I want to hit a limit. So I want to set it to that. I'm going to set it to 1 million. Or I'm going to set it to 2 million, and that should hit the limit. Maximum core stack size exceeded. So that's this. So what it does is, for me to show you, I have to demonstrate it. If I could demonstrate it in here and put breakpoints on it and everything, that will show you it going on the call stack and what happens. But anyway, let's talk about that. Let's talk about what this is doing. So what this does is, you always look at this and say, how does this calculate? How does this calculate that sum? Like if I said to you, calculate 1 plus 2 plus 3 plus 4, what you do is, you probably do a for loop for I equals 1 to n and whatever, and that will work it out. That will work it out, but you can also work it out like this. Now, just like how you do a while loop, and if you don't put something in that while loop to break out of it, it will stay in that while loop forever. It's the same with these recursive functions. In this function, that is the thing that breaks it out. Okay? Now I'm going to run with it. So I'm going to run through it with 3. So just imagine. And the answer to that is 6. Because 1 plus 2 plus 3 is equal to 6. So when I run this factorial num and it's equal to 3, it goes, if equals 0, return 0. That's false, so it doesn't do that. So what does it return? It returns num plus that. So before it can return it, it will have to calculate this. It's a bit like me doing this. A equals get wages. Before it can assign that value, you'd have to get the wages, and then when it gets the wages, it can assign it. Okay. So with this function, before it can calculate this thing, before it can do a return, so what it will do, it will come here and it will do num, which is, in our case, is 3. Alright, so it will be 3, it will try to return 3 plus, and then it will try to calculate this. So what would that be? That would basically be factorial 2. Okay. So before it can return, it would have to calculate that. So it's calling itself. So what it would do is it will then call factorial 2. Num equals 0. The answer is no. So imagine if it was factorial 2 now. Factorial 2. Imagine this now. If we ran that, what would that do? That would then be num plus factorial 1. Can you see? I wanted a way to keep it, but I'm going to have to scribble it out. So that will be 1. So what will happen is, when this gets called, that gets converted to, that's 2. So it's going to be return 2 plus factorial 1. So that will be converted to 2 plus factorial 1. So what it is, like that. What it is, this call stack here, if you could do it yourself, run this and step through the code, and you'll see that every time it goes to here, it gets added onto the call stack. So what it does is, the first time it goes through, when that's 3, it tries to return this, but it's got to calculate that. So what it does is, it pushes that on the call stack, as in it can't return until that. So it puts that on the call, it puts this on the call stack, and it carries on trying to calculate this. So even though I've got 3 and 2 there, it will keep that on the call stack, and then because factorial 1, and it's got nothing to break it out. So what it will do is it will replace that factorial 1 with 1 plus factorial 0. So that's 1 plus factorial 0. So now, when it comes to factorial 0, it will return 0. So now, that factorial 0 will return 0. And then it will start taking things off the stack. So because this got that 0, it can calculate that, it can calculate that, and it can calculate, and it can then return 6. Okay? And that's exactly what it does. So this is a recursive. So if I do 3, it returns 6. And if I do 10, it returns 55. So this min-max, the reason why I left it like that and I haven't, right, it's gonna take a board, a side, and a depth. Because if we don't keep it at depth, it's gonna go on for a very long, because we haven't got enough computer power to search the moves that are required, so we have to limit it. We have to say to it, only search to a certain depth, or else it will carry on forever, or for a very long time. So what I'm gonna do now is I'm gonna fill this out. So that is going to be a recursive function there. Okay, and it's going to have something that's going to break it out, and the thing that's going to break it out is when it reaches the depth. Okay, so once it reaches a certain depth, that's going to be the thing that breaks it out and makes it just like this. This would go on forever. If I went like this, if I put 7 here, and I put 6 as if I run it with 6, it will go on forever because it will never break out. Okay, or if I put 7.1, that's never going to be 7.1, so it will never stop. So what's gonna make this stop is that depth thing there, and what's gonna make this stop? What makes this stop is this line here. So the next video, I'm going to try to explain. I'm going to explain in depth. I'm going to explain that. I'm going to also show you a site, and this site tells you about. I'm going to use this min-max here. But what it is, I'm going to use both of these. I'm going to use the min-max first, and then at some stage I'm going to convert it to the alpha beta search because that's more efficient. And I may use that, and I may use that, and I may use this as well, iterative deepening. Okay, now this is for chess programming, but it's the same principle. Okay, thanks for watching the video. I'm gonna finish now, so goodbye.